and welcome to an algebra video learning about how to solve a linear system of equations using the substitution method. So up to this point we've talked about a linear system is just two equations modeling the same problem. Sometimes we just need to have two equations to kind of show two different things happening. And then we can graph linear systems. We can approximate where my two graphs intersect. But approximation is sort of so-so. Sometimes we want an exact answer. And so we're going to learn about the substitution method. It's an algebraic way to just kind of crunch this thing out and find the exact x and y value that make our two equations true. So here's the steps on the right. We're going to go through these each one by one. Isolate a variable, substitute, solve one variable, back substitute. We'll give meaning about what these mean as we go through step by step, but I just wanted you to have something kind of tangible that you can see what are the steps we're doing in the substitution method. Because it kind of takes several steps you can see there to get through a problem. Alright, so here's my linear system. I've got two equations. One of them is y equals 8x minus 12. The other one is y equals negative 3x plus 10. And I want to know, well, what are the x and y values, the same x and y, that I can put them in for both equations and solve them out. So here's the substitution method. Essentially what we're going to do is combine these two equations and substitute them together. So let's first step. Let's talk about what does it mean for step one, isolating a variable. Well, in one or the other equations, either one of them, I need to get either x, either y, or whatever variable I have. I want to get a variable by itself and everything else on the other side of the equation. So when I look at this one, this example is a nice one to start with because both of them are already isolated. I already have y by itself for both equations. So on this problem, step one is already done. We've already got a variable isolated. Both of them actually have a variable isolated. All right, let's talk about step number two then. This is where the name substitution method comes from. If you think about substitute, if you have a substitute teacher, you have a teacher who's taking the place, but it's supposed to be equivalent to the original teacher. Substitution means you're substituting something else in place of what was originally there. So when we have the substitution method, here's what we're doing. We're saying, okay, this y variable is equal to 8x minus 12. It's the same thing. That we have equality is hugely important. So 8x minus 12 is y. It's the same thing. But when I substitute it, this y value here is the same as this y value. So what we do then is we substitute all of this 8x minus 12 and we substitute it in place of the y value in the other equation. They're the same y value, so I can substitute what y equals. And here's what we end up with. Instead of y equals negative 3x plus 10, I now have 8x minus 12 that I substituted in place of that y. And for the rest of the equation, I still have negative 3x plus 10. Hopefully you can see why we call it the substitution method. We substitute what one part of one equation into the other equation to end up with this one big super equation. All right, so we just did substitution right there. Substitution method. Let's look at closer what we have now. We have one equation. I have 8x minus 12 equals negative 3x plus 10. That's one equation, and there's only one variable. Well, I can solve x now. If that's the only letter I have, the only variable I have, I can solve it. I could rearrange that. I could use all my algebraic methods. Let's go ahead and do that. Let's solve for x. So we're going to solve for one variable. All right, so to do that, I need to get x by itself. I'm going to add 3x to both sides. I can take these parentheses out because there's nothing multiplying in front. So I have 8x plus 3x gives me 11x minus 12 equals, these go to 0, so it just equals 10. All right, my next step, I want to get x by itself, so let's move the 12 over. The opposite of subtracting 12 is to add 12. That goes to 0, so now we've got 11x equals 22. For my final step to get x by itself, this is x multiplied by 11, so I want to do the opposite, which is to divide by 11. Now I just have 11 divided by 11 equals 1x, and that equals 22 divided by 11 is 2. All right, I've got x equals 2. Well, what does that mean? So we just solved one variable, and looks like if I was to graph these two lines, they would intersect at an x value of 2. So I have part of the solution. I'm going to write that over here. The solution is x equals 2, but I still don't know what that y value is. I still got to figure out what is the y value. I need a point, an x and a y value, so I can plot that point on the graph and know where they intersect. All right, so we've got one exact x value. I know that's the intersection point. So how do I go back? How do I actually find the y value now? Well, here's for step 4, we're going to back substitute. We know x is 2. I've got that figured out. I'm feeling very confident of that. And I have two equations that tell me how x and y relate. So when I'm saying back substitute, I'm going to put 2 in place for the x in either equation and solve for what y is. So let's just pick the first equation. Well, y is equal to 8 times x, but x is 2. We already solved that. So 8 times 2 minus 12. 8 times 2 is 16. And 16 minus 12 is 4. All right. So we just back substituted. We put the 2 in for the 8, and then we solved for the other variable. So it looks like if I was to go through now and graph this linear system, I'm going to put y equals 4 because I got that solution in there now. They should intersect at this point. Now, for part 6, checking your work, you can know on every single problem that you do using substitution, you can know if you're right, you can know if you're wrong, and it's a great way to good habit to get into, to always double check your work. And when I say check your work, you could pull out a computer program. I love using Desmos.com. The calculator is great. You can put in both equations really easily and just double check that the solution is this point right here. The other thing is you can double check actually using the equations themselves. So we used this first equation, y equals 8x minus 12, to solve for y. But let's use the other equation. Let's go back to y equals negative 3x plus 10. I can check by using the other equation and put both x and y in. So does 4, that's my y value, I'm going to put it in for y, does 4 equal negative 3 times x, but we saw x is 2, so let's just double check. Does it equal 2 plus 10? If it works for this other equation, then we've shown it works for both equations, and we just shown it's a solution. So, all right, negative 3 times 2 is negative 6, and negative 6 plus 10, it does equal 4. So we get 4 equals 4, so we just checked our work. I'm feeling really good about our solution here. The solution, using the substitution method, we substituted what one equation equals into the other one, and then just used some good old-fashioned algebra to solve it out. All right, hopefully that was a helpful introduction to the substitution method for you guys.